how can this be used? The equation, what was it? Log r equals a plus t over b has the form of a straight line, right? Y equals mx plus b. And not only does it have the correct form, but it also has the correct shape. When log r is plotted against, where'd my a go? 1 over t, oh, look at this, I messed up, I should have looked back. It's b over t. I should have looked back. When log of r is plotted against 1 over t, right, the graph makes a straight line. And that is some pretty strong evidence, right? If it looks like a rat and it smells like a rat, it's probably a rat. Okay, I think that's a phrase. Now we have to use the graph to determine the constants a and b. Determine usually means, well, it does. It means calculate, like find those values. Okay, then let's bring back our graph. A and b. Which one is the slope? Which is the y-intercept? The slope precedes, or the gradient, I should probably say, precedes x, and y equals slope times x plus intercept. So this is the intercept, b is the slope. What did I say? B is the slope. A is the y. You can't just say intercept, you actually do have to say y-intercept, because there's an x-intercept. If the graph keeps going back, eventually it hits the x-axis. That's called the x-intercept. Okay, you find the slope using the slope formula. B equals, I'll go ahead and write it out, right? y2 minus y1 over x2 minus x1. Oh, I'm not going to have enough room in those parentheses. First, I choose 2 data points on my line. They can't just be like this point or that point. They have to be points lying on the line I've drawn. So you need to draw a line so that you have points to choose. Okay, I'll choose, what should I use? I guess I'll use the y-intercept, right? Because that's something I'm going to need. I'll just call that y-intercept -2. That's easy. The x value is 0, and -2 is my y value. Make your dot nice and big, right, if you do this sort of thing. Okay, and then let's find another data point. Where is it? Oh my, look at this. Perfect. Oh my gosh. So lucky. You go down. Your x value is right between 3 and 4. 3.5. So 3.5 is the x. And what's our y value? We go over. Oh, right between 3. This is just, man, this is so nice. You love when this happens. Saves yourself some headache. Okay, let's say that you didn't have numbers that were this easy, right? You would have to look at from 0 to 1, let's say. That is 1. From here to here spans 1. And how many blocks do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each increment is 0.1. So if you had found something right here, then you would be at 0.1, 2, 3, 4, 5, 6, 0.7 is what you would have. And down here, if maybe your y value, maybe your x value came to like right here, you would say, okay, this is 1, and we subdivided it into 1, 2, 3, 4, 5, another 5, another 5, another 5. So that's 20. You would get the calculator, Mr. Buttons, 1 over 20, and now you have 0.05. Each of these little tick marks is 0.05. Right? So you have 0.05, 1, 2, 3, 4, 5, 10, 15, 16, 17 times. And you'd say, okay, this is 0.85, or something equivalent. But I've got this great line, right? I'm going to do y2 minus y1 over x2 minus x1. Wait, what did I circle? I reminded myself like 10 times of this. These values are not 3.5 and 0. It's 3.5 times 10 to the negative 3. Oh, whoops, the x value is actually 3.5 times 10 to the negative 3. I shouldn't do it that way. I should do it like this, second e, negative 3. And it's 0.0035. Oh man, I almost forgot again. So x2 minus x1 is 0.0035 minus 0. And I didn't give myself enough room in the parentheses. Shoot. And then I have y2 minus y1, that's 3 minus negative 2. And what's my answer? 3 minus negative 2, or plus 2, over 0.0035 minus 0. Ooh, wow, that's big. 14 to 9. I'll just round it there. Don't worry about units, it doesn't ask for them, and units kind of don't make sense when we take the log of a number. So that's your answer. The y-intercept is much easier. From the graph, what do you see? Mine was negative 2. I think that's reasonable. Let's hope so. Okay. Using your answer to part B, determine a value of resistance at a temperature of 260. Determine calculate resistance, right? Determine, calculate. And I have to use my answer from up here, values of A and B. Wait, I have to use values of A and B along with the value of temperature. I have an equation. I know A, I know B, I know temperature. I'm looking for R. So let's write the equation down, right? Log R. And then let's plug in. What's A? A is negative 2. And then B was 1429. It's nice to use an unrounded number right there. Oh, wait, we know T. T is 260. So let's evaluate just the right side alone. Negative 2 plus 1429 over, and that's 3.496. Got it. Wonderful. Then, remember, exponents, right? If you have log base 10 of, how do I do this? Let's do it like this. Log base number. When you take the log, it gives you the exponent. That's what you're getting from the log. It's a way to find an exponent. So the exponent is always what you get from a log. And then the base is what's down here, which is always 10, if they don't put a number down there. And then if you take this, you can rearrange it and say base to the exponent equals a number. We're trying to solve for R, which is the number. Our base is 10 because it's not otherwise listed. And what's the exponent? 10 to the this is equal to R. Base to the exponent is the number. So 10 to the 3.496 is equal to R. 10 to, oops, caret, second answer. And we get a big value, 3134. And let's round that to, I don't know, 3 sig figs seems pretty reasonable. The value of R should be in ohms. R is in units of ohms.